My name is Chun Hong Zhao, or you can call me Chloe. I am going to, on behalf of Yue Ruli, I think he is going to be here later. On behalf of him, I am going to present our study. The name is NYC Residential Property Sales. We call it is a model improvement and AI integration. So come to the background. Actually, this project is a project based on our last year program, our last year project. In the last year, Yue Ru or Norton, he did a presentation on a modeling of the NYC property sales, or how to predict the NYC property sales based on a series of features. So the data set actually is the same like the first data set we are going to use here today. The data set is we have 20 columns with 18 features and one target variable. This is our the target variables. It is NYC property sales. So in this year, we actually advanced our feature columns. We have another part of data set from the Department of Buildings. So we want to get a more accurate, more optimize the accuracy of the models. Try to combine these two data sets together. So the first data set is the comprehensive NYC property sales data, and it has 5 years, started from 2019 to 2024. And then the second data set is the Department of Building. So we call DB permit data set. So it has 22 columns, and so 21 is features. Another is the drawing key. So this is the most important part we are going to talk in detail later. So the same objective, but with the last year. So the objective is to build a robust model which can predict the sale price. So we want to transform the raw administrative data into high quality features. So here we combine the data set from the Department of Buildings. So the advantages is that it can move beyond the square footages by incorporating the building properties. The companies occupancy data to refine the property valuation. So we have more columns, or we have more features to join in. So the cool technology here is that we use the Python data frames, and we try to add a new feature columns to handle the categorical and the numerical variance across the New York diverse real estate market. So maybe we can come back to the slides later, and we dive into our coding. Here is the coding part. We used the Google Colab platform to run the code. So we go to the first lines. So here is our project names. Then the first line is that actually I am in China and do the presentation. So you can see the background is dark. So I needed to connect to the Google. I needed to combine the walls and connect to the Google. So here I'm going to run the first slide. So it is succeed. So we connected to the Google. Now then we try test it. We tested that we connected to the Google Drive successfully. Then the other slide is the code is that we're going to import the pandas as the PD. So we import the pandas here. That it succeed. Then the most important part, or we can say that is the first part, is we do the data source collection. So as I said, the data source is from the NYC Department of Finance website, and another data set is from the DOB, or Department of Building permit. This is open data NYC website. So here is the link for the from the Department of Finance link. So we can go to the link and check. Now here is the NYC annualized sales updated data. We already downloaded this data as Excel sheet. Okay, reference is the names of each columns, the meaning of each columns. I think I have already opened somewhere, so you can try open that. Then the second data set is we obtained it from API queries actually. So here is the website. So that for the Department of Finance data, it is just from the linkages and you download the Excel sheet. But the next one, we just use the API query. Now here is the permit, the DOB website, the data from the DOB, the Department of Buildings. We have the metadata information here, and you have the data of the columns, the meaning of the data from the columns. I think the most important is the blue and the block and the notes. This is columns we are going to use to join the two data sets together. Now, then we get the data. Now we're going to move on. So I combined the data, the 5-year data together. Here is a combined data set. Now we're going to try to explore. So I already merged the data set. Here is the data set from the department of the NYC property sale department. So we run, and you can see my data set. It look like here is the sales of the data, the head of the data set. The NYC sales DF is the data frame. So we have several lines, and we have several columns, including. Now we can check about the value of the blue. The blue is, we have the value 1, 2, 3, 4, 5, and the count. The meaning of the blue is here. Then we can print the shape. And then we can check the shape. So we have a lot of lines and then 21 columns. Now we have the data types of the columns. Then we can print the sale price. This is the one column, I think somewhere there. So the data set we have, we go back, we go on. The shape, the shapes of the NYC cell data frame. So we have these kind of columns. The zip code, the residential unit, total unit, land square, gross square feet, year built. So this is the most very important information. The tax classes at the time of sale, and the sale price, sale date. Then we print sale price to check the structure of the data. Then we can go more exploration, or we did that before. Now we have the information about the tax class at the time of sale. Now we check the data type for each column. Now the type is object, float, object. Now here is the information. Here is one point. We only focused on the residential tax class 1. This is the most residential properties of up to 3 units. So it including family homes and small stores, office with 1 or 2 apartments attached. So we extracted that part of the data. So we extracted the tax class at time of sale to just class 1. And then the shape it's much smaller than before. Then here is the most important part. We want to join the two data sets together. Now we create a new column. The new column we call it BBL. It is the short name from the blue block lot. So we combine these three information together. So here how we did that. We can create a column called BBL, and we convert it to the integer data type. So from the NYC sales data frame, it's a data frame 2. We can check that we have these different columns. The one column called blue, and the second column called block, and the third column called lot. The three column together is a unique ID. So if we know the building, we know the apartment or building, the blue, and we know the block, and we know the lot, then we get a unique building, a unique house, a unique apartment. So we combine these three together, we're going to get one unique ID for our property. So we combine these three together, we got another column. Here with how we did that. Then another way to do that is that we define a function. The same way, then we get a new column, so we can check the column is there. Is here. So the BBL, it has the information of the blue, and then the information of the block, and the information of the lot together. Here the type, the information, the data type of the column. So it is the object type. Then we check the data value of the columns. There are some of the value are real. So we try to describe the information. So we finished the one is the NYC sales data frame 2. Then another data frame is what we want to combine at here. Is the data frame from the department of building. Then I have already downloaded the data from the department of building. Then we think the data is here. Here is the data we're going to read from, because I already downloaded to my drive. So we are going to read this data set. So how we read that, we try to check the data set is here or not. Actually, I renamed the hidden right the exact file we needed to read. So we found that data set, we named it to file. Then the data frame called the DFDOB permit from 2019 to 2022. Then we print it, and it has a lot of lines and columns. We define the mapping. We go to the blue. We need to give our mapping name, like name and code. Then we going to create. Here is the important part as well. We create a BBL column, the same as we did before for that data set. So the column we created, because we already, as you remember, we have a function create a BBL column. So we did it for this data set as well. Then the two data sets have the same column called BBL. This is our ID, and we are going to combine these two data sets based on the BBL. Then we did the count. We just checking the data set. Checking the data set to try and make sure that we get the residential part. It is also extraction of the data set. Actually, we just use the residential part. Then we did some count. Now here the important part, we merged the two data frame together. So we merged the NYC sales data frame to another permit data set. The permit data set of the residential data set. So this is the data set. So we based on the BBL and how we did that, we did an inner connection. So we printed the data frame. Actually, now the new data frame has more than more than five, more than 35,000 lines and then 18 full columns. Then here's the shape of the date. Then this is the index of all the columns. Here is the column names and the index. We printed it to check about the missed value. Then there are some of the values are zero, so we try to check the information and drop some columns. Like some of the columns we didn't use that, so we dropped that. So the new data set, new shape of the data frame has less columns. Then we check the head now. Then now we can see we don't have zero now. Now we try to select some columns. These columns is the information that we think is going to affect the sale price. And then we just keep these columns. So we have 42 columns now. Then we installed a component called dash HTML components. Then we import some functions, pandas, plotly to try to explore the data to draw some figures. Now we explore the data set from the maps. I think some wrong here. So what we did now, what we now is that we try to map all the tables. We just have the merged tables. We just have at here, and the merged DF selected is the data set we are focusing on now. Then we try to check the information on the map. So we can do the interactive. It is interactive online showing. So we can, from each point, we can get the GIS latitude, longitude. It is the location, and then year period and other information is from the table. Or you can change the color of the points as well. Then we do another distribution of the properties and sales. It show that on the maps. It is geographic distribution. Then we import the Poultry Express as PX as well. Then we have figure. The figure is we have latitude, longitude, color, and the name, address. So it is basically geocoding. And geocoding means we have the address and then we can put it on the exact location. So we have the sale price. The sale price is the color. Actually, the sale price. You can do more exploration, changing the colors, changing the legend. Actually, the legend here is not fit the map very well. So you see here, the price at Manhattan is very high. So the color is going to be a little bit yellow. Then the price at other blue it come to blue. So you can also check the price here. Now here's the price. We're going to check some other information like the permit job type counts by the blue. So there is our data set. So we grouped it by the blue X and the job type. We're going to get another table. Is the blue and the job type and how much the count. Then we can do some other exploration, like we can based on the blue name and get a bar chart to visualize the job type across different of blue. So now here's the job type, the number of permits. The job type like A1, A2, A3 increase the permit. The job type A2 have more permits, and the job type A3 do not have much permits. Then another important part is that we're going to make the model. Then we have the columns as before. Then we try to merge the head of the table, our table. Then we do incorporate different functions. Then we do a linear regression. The linear regression here, we identify, we did some data cleaning, and like we replace the infinite values with the null data. And we have our categorical columns and then our numerical columns. Now we define the pre-processing steps into two steps. The first step is we do a simple we do a pipeline, and we do a imputer. It is a simple imputer, and then we do a scaler. It is a standard scaler. For the categorical data, we do a one-hit encoder. We combine the transformers into a preprocessor. Preprocessor is here, so we do a one-hot encoder. At here, we can combine the numerical transformer and the categorical transformer together. So in that way, we can have the preprocessor. Then now here is our numerical columns, and here is our categorical columns. The numerical columns are these kind of columns. Zip code, residential units. This kind of is our numerical columns, and we also have a lot of categorical columns. So we print this too. Now we create a train test split. So here's the model pipeline. We get a model like preprocessor, and then we have another model regressor. Now we have the training data set and then the test data set. So we create the X train, X test, and Y train, Y test with the test size is 0.3. Then we do the linear regression. We checked the mean absolute error, MAE, and the root mean square error, and the R square. Now our model actually is not very well. We can see the R square actually goes to negative. Then the second model we are going to use is the random forest. The features X and the target feature Y. The feature X is all the columns except the sale price. So the target is the sale price. And we also have the categorical columns and then the numerical columns. We also split the data into the training and the test. We have test size to 0.3. Then we also do some data cleaning. We replace the infinite values with the null data. We drop the rules with the null data values. Then we also do the pipeline. The same pipeline we do the one hot encoder is including the categorical transformer. And then we including the pass-through and so we processing for the numerical data because there is no transformation needed for the random forest, so we just pass through it, use a pass-through. Then we combine the pre-processing steps, the transformer like the numerical transformer, and then we have the categorical transformer. So we define the random forest model. This is our, then the model pipeline is our pipeline. It has the steps for process and just have the pre-process and the model. The model is a random forest model. So we train the model now. It will take some few seconds. Now the I-square, we can see the I-square is much, much higher than our linear regression. Now we move to the slide. Move to the slide here. Just we go back to the project overview. So we combined these two data sets together. We predict the sale price. So now the target variable is the sale price. Now the results we said is here's something we need to pay attention. Now the overall data frame, the overall workflow at here. So the first data set is from here is the NYC housing sales. The second part is the DOB, Department of Building Permit. So we combine these two types of data set together based on the BBL. Now we did the data warning and data analysis. So we did this part. Then we also tried the machine learning, the random forest to check the model performance. Another important part I would like to show at here is that the AI, when we want to check if the AI can help us to improve our modeling or not. So we did another part is the AI assistant training. We go back here, our coding. So we did the AI assistant building. So the AI is going to help us to build a machine learning model. So here we installed the OpenAI. Then we import the Google and import OpenAI, import the OpenAI, and then we from the Google, then we import the user data. Now we can move on to the coding. So we incorporate basically this part of the coding is we going to incorporate the OpenAI to let them to set up some key variables, some key properties, or like this kind of information, how many trees in the forest and how many the depths of the trees and the numbers of trees and the numbers of under the how many seed for the reproducibility. So this kind of information. Then finally we can the code. Actually, the code is very simple. So we can check if the performance is improved or not compared to our machine learning we just did before. So here is all the coding, all the presentation. I think the slide is almost ending. Now we can see the model quality improved or not. So the take-home message is that for the data, when we do a project or for here, we are going to try to predict the sale price. Actually, the data is from different departments. So I think for our user, we should pay attention to for the data from the different projects. We needed to combine them to try to find some ways to combine them. And for the department, for the data from the data from the different department, or like the department of so maybe they would like to find some ways to make some cooperation, so make the data more helpful for us. Another take-home message is that maybe the machine learning and the AI can help us to do a better modeling. So here is my presentation. Thank you very much. I am looking for the questions from all of you.
Hi, good morning. Thank you.
Thank you, Ben.
Hi.
Good
So,
morning.
good morning. The Department of Buildings permit data will only have data if any of the buildings filed for a permit to do work. If a building didn't do any work and it's just doing nothing, then nothing would appear in that database, right? So what happens when you're looking at properties that sold where there was no work being done or no permits being issued at the property?
That is a good question. Actually, maybe I forgot to show the coding. Actually, we just select the building, we can call that either the decoration, or they did this kind of building. What did I do you understand me? We select
only buildings that renovated themselves. Only buildings that rent. So you're looking at sales prices. So if a building didn't appear in the permits database from DOB, then you didn't include it in the algorithm in the analysis. So this only predicts sales prices of buildings that do renovation. So renovated buildings. Okay. So you can't use it to predict the sale price of a building that's unrenovated, maybe. Okay. Makes sense.
Thank you.
Yeah, thank you.
I had a quick question. Why, after regression, simple linear regression didn't give you a good fit with your R-squared method? Why did you immediately just use random forest? Was there a reason why you chose random forest versus another kind of approach?
Oh, yeah, we actually, random forest is the most popular method. We use them as a representer or something like that for the machine learning. So the random forest is one way, or we can try another different machine learning models. But here we just choose the random forest. Maybe other methods or other models have better performance than the random forest. But we didn't try it here. Maybe we can try later. I didn't try, so I don't know which model is going to be better than the random forest. So maybe it is a way we can do some work later.
I was just curious why. I know it's a really popular one right now, but was there other reasons why you specifically chose that one?
But the reason for me is that it is popular and it is most people is using that. I didn't have other reasons. Actually, I don't have other reasons why I chose that. I just into that app.
Thank you.
Thank you, Julie.
Hi, Fanny. I see you that have a question. Feel free to unmute.
Thank you for the presentation, Ms. Fa. What I'd like to ask you is about assessments on properties and market value. Would I be able to extract information based on zip codes, community boards, or the borough as a whole, based on the classifications of properties like class 1, class 2, class 3, class 4?
Let me see. Class 1, class 2. Yes. Maybe you would not we need to check another data set. That one you are talking about this columns, right? Test the class at time of the sale. I think the text class is the owner of the house.
It's class 4, let's just say S2, which is a store plus 2 residential. Would you be able to extract information on the sales from any assessment value based on a time period, and the other parameters are neighborhoods or community board? Like, how is this divided?
Oh, I didn't pay attention to that. Maybe we can check. I think it is here.
If you download the rolling sales files at Excel, you can filter by zip code or neighborhood. You can filter by tax class at time of sale or by building class. So if you just want to see all of the S2s that sold in Astoria, you could just filter for those things, just right in the Excel file. You don't have to do any programming.
Oh, okay, great. And I have another question. How would you be able to, from DOB, all temporary CBOs in a borough? On the DOB, Department of Buildings, I don't know if I could ask you this question. It's temporary, a certificate of occupancy. Will you be able to extract that data from the DOB data?
Yeah. The DOB data is also open data, but it is in a way like linkage. As I said before, we can extract that. We need to download. No, we need to just use that online. This is from the API queries.
Okay.
Yeah, we downloaded that from the API queries. So for your last question, thank you very much for the audience help me to answer. Actually, I didn't get your points very well. I think maybe you are talking of I was thinking you are talking about the definition of the columns. Actually, the definition is all at here. So you can check this, or you can download text class as you can see.
So I have another question. I'm not clear. So I know you divided with class 1. So basically either 2 or 3 families or combined with the store. But you use only data from sales and you train the data with a linear regression. But what is this program will allow you to predict? The sales price, or if it's going to sell, or the increase of the price? I'm not clear about what is the result. What will help me predict?
We select some columns. We think that kind of columns is going to help us to make the prediction. I think
But the prediction is on the price, or if it's going to sell, or
the price, the sale. It is one columns on the property sale. I think it is already that the column is already there. It's a sale.
So what is this model train the data? What is going to tell? What is going to predict?
It's going to predict in the future if we have other columns or we have the information of other columns, we can predict the price of that department, how much is going to be sold in the future.
Okay, so basically the difference in price, the different price. And do you because my question is, you only took, so I don't know if you're aware, but usually builders try to get a lower permit, right? They try to get away with paying less to the city. So they might file for one permit, but they're actually doing more work. And so basically they state that most of them, unless it's a new construction or they're doing a whole renovation, they usually try to pay less with the government. So my question is, like, when you divided this for permit class, do you find any kind of prediction with the price or no for class 1, class 2, class 3?
Actually, I do not have a good answer for the questions. Maybe later on we can talk later from the email. I didn't do the work. I didn't separate the model regression for different kind of work permits. Maybe can be a good direction. I didn't try the model works for properties with no permits. The model actually ran by Norton Lee. He is not here today. He had some internet issues and his work is now in China as well.